So they have spoken to you so much about electricity, magnetism, and demonstrated experiments. So if you have to really understand all those phenomena, there's a certain language in which you have to ask questions. And that language is not any of the languages that we speak. That language is the language of mathematics. Ultimately, the language of science is mathematics. So if you have to be good at science, then you should be good at mathematics. When you ask a question about any phenomenon, you ask in a mathematical language. What do we mean by that? When I say we use mathematical language, we use numbers, we use measurements, we use geometry. So it is not surprising that the person who introduced experiment as a method of doing science, Galileo, is credited with this contribution to science. He says that the language of nature is mathematics and her words are circles, squares and triangles. What does he mean by this? He means to say that if you are not putting your questions in the language of mathematics, there is no way you will get answer from nature. And secondly, the words that you use to ask these questions are circles, triangles and squares. What do these have in common?
Shapes.
They are shapes. They are all geometrical shapes, right? Well-defined geometrical shapes. So geometry as a language, geometry as a way of thinking, geometry as a way of solving problems. So geometry ನೀವು ಎಷ್ಟೋ ಥಿಯರಿಗಳನ್ನು ನೀವು ಡಿರೈವ್ ಮಾಡ್ತೀರಾ, ಪ್ರೂವ್ ಮಾಡ್ತೀರಾ, ಮತ್ತೆ ಅದನ್ನು ಉಪಯೋಗಿಸ್ಕೊಂಡು ಎಷ್ಟೋ ಪ್ರಾಬ್ಲಮ್ಸ್ ಎಲ್ಲ ಸಾಲ್ವ್ ಮಾಡ್ತೀರಾ. Geometry becomes the ultimate language of mathematics also. Because many of you are in PUC that have already done some analytical geometry, trigonometry, calculus, integral calculus, differential calculus. So what is common to all of them is geometry. So there is nothing more than that. And so much so that arithmetic is also geometry. You think about this statement deeply sometime. We don't have much option for us to discuss that in detail here now, because we have to get out to sound very quickly. Arithmetic is also a language of geometry. Arithmetic is also a language of geometry. Algebra also is a language of geometry. Everything is geometry. So much so that ancient philosophers, whether east or west or any place, one common thing they believed was that if at all there is somebody like God, then that God is a great geometer. So that God must have enormous fondness for geometry. That is what most philosophers thought about in ancient times. So if you are doing more and more of geometry, that is one way of going closer and closer to God. Like, okay? So whatever it means, God could be nature. So understanding nature is like understanding God, and to understand God, you need language of mathematics, and you need to be good at geometry. So if you have any doubts about whether you should do mathematics or not, especially if you want to do science at higher levels, take it from me, you cannot escape from mathematics. If you're not good at mathematics, then you can't be good at science. So that is the language that we use. So what I'll try to do today is to impress upon you how this language of mathematics is important to understand many aspects of natural phenomena. Because we cannot go out in nature and study these things, we have artificially created all those things that we will find in nature here, and we will see how to ask good questions about these demonstrations, experiments. If you don't ask questions about these experiments, then you have not understood much. ನೋಡಿರ್ತೀರಾ, ಅದನ್ನು ನೋಡಿ ಖುಷಿ ಪಟ್ಟಿರ್ತೀರಾ. So that is the only takeaway from this place, the happiness. But something beyond that, there are two kinds of happiness. One is you see immediately you find it very interesting and you are very happy. You may laugh, you may clap and you may jump with joy. You can do all sorts of things. But the other kind of happiness is the ultimate one. When you realize what is the real reason behind something happening there, that gives you a kind of joy which is priceless. that is priceless. And that kind of a state of mind you can go where you have really understood what is happening here, and in order to do that, you will find that mathematics is the staircase that you have to climb. That's the point I want to try to do. And sound is only an excuse, but whatever we do with sound, you can generalize with all the scientific phenomena that you study, including electromagnetism that my friends Gopal Krishna and Viswan have demonstrated. Get into this way of asking questions. Otherwise, looking at these experiments will be no better than watching a PC Sarkar magic show. Magic show gala ishta alva namge. Yathಕ್ಕೆ ಇಷ್ಟ ಆಗುತ್ತೆ ನಮಗೆ ಮ್ಯಾಜಿಕ್ ಶೋ? ಯಾತಕ್ಕೆ ಅದು ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಆಗುತ್ತೆ? ಏನು ಮಾಯ ತರ ಇರುತ್ತಲ್ಲ, ನಾವು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡದೇ ಇರೋದಾಗ್ಬಿಡುತ್ತೆ ಅಲ್ಲಿ. ಸಡನ್ ಆಗಿ ಏನೋ ಒಂದು ಎಕ್ಸ್ಪ್ಲೋಷನ್ ಆಗುತ್ತೆ, ಏನೋ ಒಂದು ಕಡೆ ದೊಡ್ಡದಾಗಿ ಒಂದು ಲೈಟ್ ಬರುತ್ತೆ, ಅಥವಾ ಅಲ್ಲಿ ಇದ್ದವರು ಒಂದು ಸೆಕೆಂಡ್ ಅಲ್ಲಿ ಮಾಯ ಆಗ್ಬಿಟ್ಟಿರ್ತಾರೆ. These are things which we don't expect to happen normally. So anything that we don't expect to happen normally will always be interesting to us. That is what a magician tries to do. They don't show you normal things like I'm showing. But the difference between a magician and a person who does science is that a magician uses science to create magic, but the magician will never tell you the secret how it works. But a man of science, a woman of science, a person of science will perform the same kind of magic, but it doesn't look like magic to you because you understand what is happening there. Do you get that? That's the only difference between science and magic. So magicians never tell, like in the Mandrake comics, if you have read, magicians never tell is a very famous thing that the Mandrake keeps telling you. But as students of science, you can't leave science to a magician. You have to actually open the box, see what is inside, and see how different parts are arranged and how they talk to one another in order to create the phenomenon that you see or hear. Okay? And in order to completely understand how these things work, measurement is very important. This is where mathematics comes. If you did not make any measurement in an experiment, you have never done an experiment. You have done a magic demonstration. But if you want to claim that you have done something which is scientific, you want to say that I have understood now like a student of science, you are sitting in a place where C.V. Raman walked, breathed day in and day out. One of the greatest experimental physicists India has produced. So if you look at all his works, measurements are at the heart of every investigation of every experiment. Adhan ಮಾಡ್ತಿರ್ತಾರೆ. ಅದು ಮಾಡ್ತಾ ಹೋದ್ರೆ ನೀವು ನೋಡಿ ಖುಷಿ ಪಟ್ಟಿರ್ತೀರ, ಹೊರಟೋಗಿರ್ತೀರ, that's the end. You would not have understood much. So this point I wanted to make it clear to you. So look at the experiments, whether here or they demonstrate or somebody else demonstrates, or you watch on YouTube, and you want to repeat the experiment, fine. That is the first stage of learning, that's not the last stage. So what we do here today is a beginning. It's not the end of any experiment. No experiment will end today. Every experiment will only have a beginning. You have to take it to an end by asking right kind of questions. ಇದ್ಯಾಕೆ ಹೀಗಾಗುತ್ತೆ, ಇದು ಈ ಥರ ವ್ಯತ್ಯಾಸ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? Suppose I alter some parameter, length or breadth or thickness, then what is the effect of that on the phenomena that I am studying? These are the questions you ask. And for all these answers, measurements will be there. Because you have to make some measurement and find a relation between different things that are involved in the phenomenon. So when you make these measurements and you establish a relationship, the ಉದ್ದ ಜಾಸ್ತಿ ಆದರೆ ಶಬ್ದ ಹೇಗೆ ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗುತ್ತೆ, ಶಬ್ದದಲ್ಲಿ ಅದು ಕಂಪನಾಂಕದಲ್ಲಿ ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗುತ್ತೋ ಅಥವಾ ಅದು ಎಷ್ಟು ಜೋರಾಗಿ ಕೇಳಿಸುತ್ತೆ ಅದರಲ್ಲಿ ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗುತ್ತೋ, ಇದನ್ನು ನಾವು ಮಾಡ್ಬೇಕಂತ ಹೇಳಿದ್ರೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿ. ಸುಮ್ಮನೆ ಹೆಚ್ಚಾಯಿತು ಕಡಿಮೆ ಆಯಿತು ಅಂತ ಹೇಳಿದ್ರೆ ದಟ್ಸ್ ಎ ವೆರಿ ಸ್ಮಾಲ್ ಸ್ಟೆಪ್ ಯು ಹ್ಯಾವ್ ಅಂಡರ್ಸ್ಟುಡ್. ಉದ್ದ ಹೆಚ್ಚಾದ್ರೆ ಕಂಪನಾಂಕ ಕಮ್ಮಿ ಆಯಿತು, ಅದು ಒಂದು ಸ್ಮಾಲ್ ಸ್ಟೆಪ್. ಬಟ್ ಎಷ್ಟು ಉದ್ದ ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಕಂಪನಾಂಕ ಕಡಿಮೆ ಆಗುತ್ತೆ ಅನ್ನೋದು ನಾನು ಏನಾದ್ರು ಪತ್ತೆ ಹಚ್ಚಿದ್ರೆ then I have done something scientific. This is what every scientist does. Is it a very difficult thing to do? So scientists are not superhuman beings. They do the same things that I am telling you day in and day out. That is something that you and I also can do. So we are all born scientists, but we make a huge effort not to become scientists. We put in a lot of effort. By that, what do I mean? I don't mean that you don't take up science. I mean you kill that ability to ask questions. ನಿಮ್ಮಲ್ಲಿ ಪ್ರಶ್ನೆ ಕೇಳೋ ಸಾಮರ್ಥ್ಯ ಇದೆಯಲ್ಲ, ಅದನ್ನು ನಮ್ಮಷ್ಟಕ್ಕೆ ನಾವೇನೇ ಅದನ್ನು ಕುಗ್ಗಿಸ್ಬಿಡ್ತೀವಿ, ಕಡಿಮೆ ಮಾಡಿಬಿಡ್ತೀವಿ. ಅದನ್ನು ಕಡಿಮೆ ಮಾಡಿದಾಗ, ಕುಗ್ಗಿಸಿದಾಗ, ಅದನ್ನು 0 ಮಾಡಿದಾಗ ನಮ್ಮಲ್ಲಿರೋ ಸೈಂಟಿಸ್ಟು ಸತ್ತೋಗಿರ್ತಾನೆ. ಸೊ ನಮ್ಮಲ್ಲೆಲ್ಲ ಸೈಂಟಿಸ್ಟು ವಿತ್ ಬರ್ತ್ ವಿ ಆರ್ ಆಲ್ ದೇರ್, ಬಟ್ ದೆನ್ ವಿ ಸ್ಟಾಪ್ ಆಸ್ಕಿಂಗ್ ಕ್ವೆಶ್ಚನ್ಸ್, we stop making measurements, we stop establishing the relationship, and that is when the scientist in us dies. So if you want to keep the scientist in your life, you should do these simple tasks. Experiment ಮಾಡಬೇಕು, ಪ್ರಶ್ನೆ ಕೇಳಬೇಕು, measurements ಮಾಡಬೇಕು, ಅದರಲ್ಲಿರೋದಕ್ಕೆ ತಾಳೆ ಹಾಕಬೇಕು. ಇಷ್ಟು ಮಾಡಿದ್ರೆ that's all every scientist does. Okay, that's what I'm going to do with some simple demonstrations. Okay, so shall we start? Right. So, where do we begin? So, let me begin with a toy which is very, very commonly found. ಇದೆಲ್ಲ ಸಣ್ಣ ಮಕ್ಕಳಾಗಿ ನೀವು ಈ ಥರದ ಒಂದು ಟಾಯ್ ನೋಡಿರ್ತೀರಲ್ಲ, you would have seen this toy and many of you have played with this. ಇದು ಏನಾಗುತ್ತೆ? ಯಾರಾದ್ರೂ ಹೇಳ್ತೀರಾ ಇದು ಟಾಯ್ ನ ಕೆಲಸ ಮಾಡೋದು ಹೇಗೆ ಅಂತ? Yes. Okay. Pick ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? Different sound. So first let us find out whether this is true. Different sound anta. ಇದು ಯಾವ ರೀತಿಯಲ್ಲಿ ಡಿಫರೆಂಟ್ ಆಗಿದೆ?
ಇದು
ಒಂದೊಂದು ನೋಟ್ ತರ ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ, ಸಂಗೀತದ ನೋಟ್ಸ್ ತರ ಇದೆ. ಬಟ್ ಆಕ್ಚುಲಿ ಈ ಸೌಂಡ್ ಅನ್ನ ನಾವು ಡಿಸ್ಕ್ರೈಬ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಇದನ್ನ ನಾವು ಯಾವ್ದಾದ್ರು ಸೌಂಡ್ ಇಲ್ಲಿರೋ ಸೌಂಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅಷ್ಟೇ ಸಾಕು. ಆ ಸೌಂಡ್ಗೆ ಸಂಬಂಧಪಟ್ಟಾಗೆ ಒಂದಷ್ಟು ಗುಣಲಕ್ಷಣಗಳು, ಸಮ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ಸೌಂಡ್, ಅಂಡ್ ವಿ ಯೂಸ್ ದೀಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ಟು ಕನ್ವೆ. ಸೊ ಈಗ ಪ್ರತಿಯೊಂದು ಪೈಪನ್ನು ಬಡಿದಾಗ ಶಬ್ದ ಬರ್ತಲ್ಲ, ಒಂದು ಪೈಪಿಂದ ಇನ್ನೊಂದು ಪೈಪ್ ಬಡಿದಾಗ ಶಬ್ದ ವ್ಯತ್ಯಾಸ ಆಯ್ತು ಗೊತ್ತು ನಮಗೆ. ಯಾವ ತರದಲ್ಲಿ ವ್ಯತ್ಯಾಸ ಆಯ್ತು? Sorry? Somebody said frequency. ಯಾರು ಹೇಳಿದ್ರು? ಹೇಳಿ ಪರವಾಗಿಲ್ಲ. So right or wrong, it doesn't matter. As long as you are talking to me, I am very happy. Okay? So frequency. So frequency ಅಂದ್ರೆ ಏನು? Disturbance ಇಂದ sound ಬರುತ್ತೆ. Frequency ಅಂದ್ರೆ ಏನು? Sorry?
Number of wavelengths per second.
Number of wavelengths per second. Okay, that's one way of putting it. Frequency and then first of all, for any sound to be produced, there is one essential condition. School ಗಳಲ್ಲ ಕಲ್ತಿರ್ತೀರಾ in 9th class. How is sound produced? By vibration. So anything that vibrates, it makes a to and fro motion like this, back and forth. ಅಲ್ವಾ? ಇದು 1 ಸೆಕೆಂಡ್ಗೆ ಎಷ್ಟು ಸಲ ಅದು ಒಂದು ಸೈಕಲ್ ಕಂಪ್ಲೀಟ್ ಮಾಡುತ್ತೆ ಅಂತ ನಾವು ಕೌಂಟ್ ಮಾಡಿದ್ರೆ ಅದಕ್ಕೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ಕರಿತೀವಿ. And what is the unit of frequency? Hertz. So when I say that something has a frequency of 10 hertz, what does that mean?
10
times. Okay, within a second it vibrates 10 times. Now what is the frequency that we just about can hear?
20,000.
ಇದು ನಿಮ್ಮ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದಾರೆ, ನೀವು ಅದನ್ನ ತುಂಬಾ ಶ್ರದ್ಧೆಯಿಂದ ಕಲ್ತ್ಕೊಂಡಿದ್ದೀರಾ. 20 hertz to 20,000 hertz. You can do a simple experiment. Now, how do you find out whether human beings actually, for example, yourself, 20 hertz and 20,000 hertz ಅಂತ ನೀವು ಕೇಳಿಸಿದ್ರೆ ಅಂತ ನೀವು ಹೇಗೆ ಕನ್ಫರ್ಮ್ ಮಾಡ್ಕೊಳ್ತೀರಾ? ಮ್ಯೂಸಿಕ್ ಪ್ಲೇ ಮಾಡ್ತೀರಾ? ಸೊ ನೀವು ಪ್ಲೇ ಮಾಡ್ತಾ ಮ್ಯೂಸಿಕ್ ಎಷ್ಟು ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ಹೇಗೆ ಗೊತ್ತಾಗುತ್ತೆ? Whether it's 20 hertz or 25 hertz or 30 hertz, how do you know? You get an instrument. And what do you do with that instrument?
You set the frequency.
You set the frequency. Okay. I want to introduce you to one very interesting app which you can freely download on your mobile phones. ಈಗ 2 ನಿಮಿಷ 3 ನಿಮಿಷ ಬಿಟ್ಟ ಮೇಲೆ I'll show one by one experiments very quickly, but we will have lots of questions to ask. ಈ ಆಪ್ ಹೆಸರು ಏನಂತ ಹೇಳಿದ್ರೆ ಇದಕ್ಕೆ ಫಿಸಿಕ್ಸ್ ಟೂಲ್ ಬಾಕ್ಸ್ ಸ್ವೀಟ್ ಅಂತ ಹೆಸರು. ಫಿಸಿಕ್ಸ್ ಟೂಲ್ ಬಾಕ್ಸ್ ಸ್ವೀಟ್ SUITE. ಇದು ನಿಮಗೆ ಗೂಗಲ್ ಪ್ಲೇ ಸ್ಟೋರ್ ಹೋದ್ರೆ ಫ್ರೀಯಾಗಿ ಡೌನ್ಲೋಡ್ ಮಾಡಿ. ಏನಾ ಇದನ್ನ ಡೌನ್ಲೋಡ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಈಗಲೇ ಮಾಡಬೇಡಿ. I appreciate your interest, but just to keep going quickly. We don't have much time, alva? So, ಇದನ್ನ ಡೌನ್ಲೋಡ್ ಮಾಡಬೇಕು. ನಿಮ್ಮ ಮೊಬೈಲ್ ಫೋನನ್ನ 10 ರಿಂದ 15 ಬೇರೆ ಬೇರೆ ಉಪಕರಣಗಳಾಗಿ ಮಾರ್ಪಡಿಸಬಹುದು. You can convert your mobile phone into very powerful, highly precise measuring instruments. It will measure speed, acceleration, loudness of sound, frequency of sound. It will produce sound of different frequencies. Then you can measure strength of magnets. ಇದರದ್ದು ತುಂಬಾ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡ್ಕೊಂಡಿದೆ. ನೀವು ನಿಧಾನಕ್ಕೆ ಇದನ್ನ ಆ್ಯಪ್ ಜೊತೆಗೆ ಆಟ ಆಡ್ಕೊಂಡೆ ನೀವು ಕಲ್ತ್ಕೊಂಡ್ಬೋದು. I will just talk only about sound related part of this app. Okay? So ಈ ಆ್ಯಪ್ ಅನ್ನು ನೀವು ಓಪನ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾಗ ಇದರಲ್ಲಿ ಒಂದು ಟೋನ್ ಜನರೇಟರ್ ಅಂತ ಇರುತ್ತೆ. ಮತ್ತೆ ಶೋ ಯು ಹೌ ಇಟ್ ವರ್ಕ್ಸ್. ಇದರಲ್ಲಿ ಒಂದು ಟೋನ್ ಜನರೇಟರ್ ಅಂತ ಬರುತ್ತೆ. ಓಕೆ, ಇದು ಟೋನ್ ಜನರೇಟರ್ ಅಂತ ಇದು ಸ್ಕ್ರೀನ್ ಬರುತ್ತೆ. ಇದರಲ್ಲಿ ನಾನು ಬೇರೆ ಬೇರೆ ಫ್ರೀಕ್ವೆನ್ಸಿಯನ್ನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಬೋದು. ಇದರಲ್ಲಿ it is displaying a number there, 2643 hertz ಅಂತ. ಇದನ್ನ ಒಂಚೂರು ಕಮ್ಮಿ ಮಾಡ್ತೀನಿ. ಇದು 1000 hertz ಅಥವಾ 1 ಕಿಲೋ hertz ಇದು. ಇನ್ನೂ ಜಾಸ್ತಿ ಮಾಡ್ತೀನಿ. This is 9000 kilohertz. ಓಕೆನಾ? ಈಗ ನಾನು ಯಾವುದೋ ಒಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ತಗೊಂಡು ಹೋಗ್ತೀನಿ. You have to tell me honestly whether you are able to hear or not. Okay? Are you able to hear?
Yes, sir.
Really?
Yes, sir.
Honestly, I am not able to hear this. You are much younger. Right? You are much younger. With age, we lose our ability to hear higher frequencies. ಯಾಕೆಂದ್ರೆ ನೀವು ನಿಮ್ಗೆಲ್ಲ 15 ವರ್ಷ ಅಷ್ಟೇ. ನನಗೆ 57 ವರ್ಷ ಆಗಿದೆ. 57 ವರ್ಷದಲ್ಲಿ ಬೆಂಗಳೂರು ಟ್ರಾಫಿಕ್ ಅಲ್ಲಿ ಇದ್ದು ಏನಾಗುತ್ತೆ sensitive, not joking. It is really happens when you are exposed to a lot of sound for a long period of time, like in my case 57 years, you find that the sensitivity of the ear goes down. So it's not surprising that I am not able to hear. You can listen here. Okay. Diga? Sure. Diga? Play ಮಾಡಿದ್ರಿ. Can you hear?
Yes, sir.
Right.
Yes, sir. Yes, sir. Yes, sir.
ಹೆಸರು ಕಡಿಮೆ ಆಯ್ತು.
Yes, sir.
Now you don't have to say yes because ಅಯ್ಯೋ ನಾನು ಎಸ್ ಅಂತ ಹೇಳಿಲ್ಲ ಅಂದ್ರೆ ನಾನು ಕಿವಡ ಅನ್ಕೊಂಡ್ಬಿಡ್ತೀನಿ. No. You should be honest. That's the first important thing in science, okay?
Yes, sir.
Yes, sir.
Yes,
sir. Wait. Silence. Honestly, put your hand up. No problem. Okay. Next up. One last time. Ega?
No.
Now look at the reading.
18,000.
18,000. So your textbook is like 20 to 20,000 hertz ಅಂತ ಹೇಳಿದಾಗ, that is only under very ideal conditions. Now, if I did not make a measurement, it's very difficult to say what is the range of my hearing. So even a simple experiment like what is the range of hearing needs measurement. Now, all of it did not stop listening at the same frequency. ಅದು ಕ್ರಮೇಣ ಕಡಿಮೆ ಆಗ್ತಾ ಬಂತು. ನಂತರ 8,000ಗೆ ಮುಗ್ದಾಯ್ತು. Few people went up to 16,000. And 17,000-18,000 people could not hear. So which means even amongst us there is a big range of difference. There's a big difference. Now will it not be a nice project for you to use this app? Go around in your class, collect as many people as possible, collect data from each one of them, and then you plot a graph how it varies. And then you can do this from first standard to 12th standard if your school has. ಅವರು ತೀರಾ ಸಣ್ಣ ಮಕ್ಕಳಲ್ಲಿ ಎಷ್ಟು ಸೆನ್ಸಿಟಿವ್ ಆಗಿರುತ್ತೆ, they may be able to get even 19,000 hertz which you could not hear. By the time you come to my age, with more traffic you would have lost even 8,000 hertz that I hear. Possible. This is a nice simple experiment. But to ask the question, what is the range of human hearing? Textbook al kottidare, so I should just repeat that in the exam. That's not the way you do science. You actually test that. But to test that, measurement is required. Okay? And then when you collect a lot of data, then you can do statistical analysis. Statistics ಹೇಳ್ಕೊಡ್ತಾರೆ 9th to 10th ಅಲ್ಲೆಲ್ಲ ಡೇಟಾ ಹ್ಯಾಂಡ್ಲಿಂಗ್ ಗೊತ್ತಲ್ಲ, ಕ್ಲಾಸ್ 7 ರಿಮೆಂಬರ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಕ್ಲಾಸ್, ಡೇಟಾ ಹ್ಯಾಂಡ್ಲಿಂಗ್ ಅಂತ ಅದು 5ನೇ ಕ್ಲಾಸಲ್ಲಿ ಶುರು ಆದರೆ 10ನೇ ಕ್ಲಾಸಲ್ಲೂ ಎಂಡ್ ಆಗಲ್ಲ, ಓಪನೇ ಇರುತ್ತೆ. ಸೊ ಯು ಲರ್ನ್ ಡಿಫ್ರೆಂಟ್ ವೇಸ್ ಆಫ್ ಹ್ಯಾಂಡ್ಲಿಂಗ್ ಡೇಟಾ. Now you can see what you can do with this kind of a data. You can find whether there is a gender bias, whether boys can hear more up to on an average more higher frequency than girls, or is it the girls who have a higher frequency range than boys? And if you find this to be true, then the next thing is, why is it like this? Why on an average girls should be more sensitive to high frequencies and why not? This kind of question is not a simple question. In biology, in the world of animals, when we study the behavior of animals, this is an extremely important thing. Because even the ಹೋದ್ಮೇಲೆ internet search ಮಾಡಿ ಒಂದು data collect ಮಾಡಿ, you find the hearing range of sound of animals. Table ಸಿಗುತ್ತೆ ನಿಮಗೆ. ಅದೇ ರೀತಿ same animals, what is the range of sound that they can produce? Do you think these two ranges will be the same? For example, you can hear up to let's say 18,000 hertz. Can your voice box produce 18,000 hertz sound? It cannot. It will hardly produce 3,000, 4,000 hertz. That is the case with all animals. The sound production frequency range is lot smaller than the sound hearing frequency range. Now, when you have a lot of data, you have a question to ask. Is it not a good scientific question? ಎಲ್ಲ ಪ್ರಾಣಿಗಳಲ್ಲೂ ಅದು ಕೇಳಿಸ್ಕೊಳ್ಳೋ ಫ್ರೀಕ್ವೆನ್ಸಿ ಹೈಯರ್ ಇರುತ್ತೆ, ಆದರೆ ಅದು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋ ಫ್ರೀಕ್ವೆನ್ಸಿ ಕಡಿಮೆ ಇರುತ್ತೆ. ಸೊ ಇಫ್ ದಿಸ್ ಪ್ಯಾಟರ್ನ್ ಇಸ್ ದೇರ್ ಅಕ್ರಾಸ್ ಆಲ್ ಆನಿಮಲ್ಸ್ ಇನ್ ದ ಅನಿಮಲ್ ಕಿಂಗ್ಡಮ್, ದೇರ್ ಮಸ್ಟ್ ಬಿ ಸಮ್ ಸ್ಟ್ರಾಂಗ್ ಸೈಂಟಿಫಿಕ್ ರೀಸನ್ ಫಾರ್ ದಿಸ್. ದ ವೇ ದ ವಾಯ್ಸ್ ಬಾಕ್ಸ್ ಇಸ್ ಡಿಸೈನ್ ಅಂಡ್ ದ ವೇ ದ ಇಯರ್ ಇಸ್ ಡಿಸೈನ್ ಮ್ಯಾಚ್ ಆಗ್ತಾ ಇಲ್ಲ. ಸೊ this is a starting point. See how many questions you can ask by just having one measurement. So you can try to do these kinds of measurements. You can measure frequency using that app. Then you can also measure amplitude. Amplitude is loudness, maximum displacement of any oscillating. That is related to loudness. Amplitude ಜಾಸ್ತಿ ಇದೆ, loudness ಜಾಸ್ತಿ ಇರುತ್ತೆ. What is the unit of measurement of loudness? In area? Hertz is frequency. Decibel. Decibel. So decibel is the unit of measurement. What is the normal? As I am speaking to you, how many decibels am I producing? That I should know. ಪುಸ್ತಕದಲ್ಲಿ ಡೆಸಿಬಲ್ ಡೆಫಿನೇಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ, ಅದು ಯಾವ್ಯಾವ್ದ್ರದ್ದು ಇಷ್ಟೆಷ್ಟು ಡೆಸಿಬಲ್ ಅಂತ ಕೊಟ್ಟಿರ್ತಾರೆ, ಬಟ್ ದಟ್ ಡಸಂಟ್ ಟೀಚ್ ಯು ಎನಿಥಿಂಗ್. When you have a measuring instrument like this and you can tell very precise, at least a range, ಈಗ ನಾನು ಮಾತಾಡ್ತಾ ಇರೋದು ಒಂದು 60 to 70 ಡೆಸಿಬಲ್ಸ್ ಇದೆ. ಈರುಳ್ಳಿ ಪಟಾಕಿ ಹೊಡೆದ್ರೆ ಒಂದು 150 ಡೆಸಿಬಲ್ಸ್ ಬರುತ್ತೆ. ಕುದುರೆ ಪಟಾಕಿ ಹೊಡೆದ್ರೆ ಒಂದು 80 ಡೆಸಿಬಲ್ಸ್ ಬರುತ್ತೆ. ಈ ತರದ್ದು ನಮಗೊಂದು ರೇಂಜ್. ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಯು ಹ್ಯಾವ್ ದೀಪಾವಳಿ, ಯು ಕ್ಯಾನ್ make these kinds of measurements also. Okay, it's fun. So I'll very quickly go to the experiments now. Before that, I want you to be clear about one thing: frequency. The other thing is amplitude. So these two measurements, amplitude and frequency, that describes everything that you want to know about any kind of sound. ಆ ಸೌಂಡ್ ಯಾವುದೇ ಒಂದು ಇನ್ಸ್ಟ್ರೂಮೆಂಟಿಂದ ಬರ್ತಿರಲಿ, ಪ್ರಾಣಿಯಿಂದ ಬರ್ತಿರಲಿ, ಅಥವಾ ಮತ್ತೊಂದು ಮೆಥಡಿಂದ ಬರ್ತಿರಲಿ, ಓನ್ಲಿ 2 measurements are what you do. I am not considering wavelength for a certain reason. So frequency and amplitude. ಇದೆರಡು ನೀವು ಈ ಆ್ಯಪ್ ಮುಖಾಂತರ ಮಾಡ್ಬೋದು. ಸೊ ಈಗ ನಾನು ತೋರಿಸೋ ಪ್ರತಿಯೊಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ಲೂ you can try to find out how the frequency changes when certain parameters are changed in the experiment, and how the amplitude changes when certain parameters are changed. Is it okay? Because if I didn't introduce this measurement part, I will not excuse myself, because that is not science. Measurement is absolutely essential. Okay, now, so coming back to this experiment, can someone tell me a good question to ask about this experiment? ಈಗ ನಾನಿಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಪೈಪನ್ನು ಬಡಿದಾಗ ಬೇರೆ ಬೇರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಬಂತು. Now you have the app. You can make measurements. So what question will you ask and what measurement will you do? Those quick
Which produces the highest frequency?
My name, sir.
Which produces the highest frequency?
So which of the pipes produces the highest frequency? So I have one shortest pipe and one longest pipe. Which of the two will produce highest frequency? It has to be one of them. Right? Only 2 options. Listen to this. First I am going to strike the shortest one. Now the longest one. Shortest one. Now if I ask you, what was the frequency produced by the shortest pipe? ಅದು ಕಷ್ಟ. ಇದೆರಡು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಇದು ಕಡಿಮೆ ಇದೆ, ಹೆಚ್ಚಿದೆ ಅಂತ ಗೊತ್ತಾಯ್ತು. ಇದ್ರ ಫ್ರೀಕ್ವೆನ್ಸಿ ಎಷ್ಟಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ ಅದು ಹೇಳಕ್ಕಾಗಲ್ಲ. Now you need some measuring instrument to produce. Now you can actually do a very interesting thing. ಇಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಲೆಂತ್ ಇದೆಯಲ್ಲ, ಈ ಲೆಂತ್ ಚೇಂಜ್ ಆಗ್ತಾ ಇದ್ದಂಗೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ಯಾವ ಪ್ಯಾಟರ್ನ್ ನಲ್ಲಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಇದಕ್ಕಿಂತ ಇದು 2 ಸೆಂಟಿಮೀಟರ್ ಜಾಸ್ತಿ ಆದ್ರೆ ಫ್ರೀಕ್ವೆನ್ಸಿನಲ್ಲಿ ಎಷ್ಟು ಹರ್ಟ್ಸ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಇದಕ್ಕಿಂತ ಇದು 2 ಸೆಂಟಿಮೀಟರ್ ಉದ್ದ ಆಯ್ತು, ಅದರಿಂದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇದಕ್ಕೂ ಎಷ್ಟು ವ್ಯತ್ಯಾಸ ಆಯ್ತು. Is it a good question to ask?
Yes, sir.
Rather than just say this is more, this is less. Right? So now, if you make this pipes of various lengths and you plot a graph, length of the pipe versus frequency it produces, then try to see a pattern in the graph. PUC ಮಕ್ಕಳೆಲ್ಲನೂ ನೀವು analytical geometry ಎಲ್ಲ ಮಾಡ್ತಿರ್ತೀರ. So ಹಾಗಾಗಿ ನಿಮಗೆ to get the equation of a curve is not very difficult. So curve ಬರುತ್ತೆ, ಆ curve ಯಾವ equation fit ಆಗುತ್ತೆ ಅಂತ ಮಾಡಿದ್ರೆ you would have done a fantastic physics experiment. If I just hit those different pipes and just show you that they are all of different frequencies, that is not science. When you establish a relation between ಇಷ್ಟು ಲೆಂತ್ ಇದ್ರೆ ಇಷ್ಟು ಫ್ರೀಕ್ವೆನ್ಸಿ ಬರುತ್ತೆ ಅಂತ. ನೆಕ್ಸ್ಟ್ ನಾನು ಕೇಳ್ತೀನಿ, ಈ ಸೆಟ್ಟಲ್ಲಿ ಇಲ್ಲದೆ ಇರುವಂತದ್ದು ಯಾವುದೋ ಒಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ನನಗೆ ಬೇಕು. ಇದೊಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಬರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ಒಂದು ಇನ್ನೊಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಬರುತ್ತೆ, ಇನ್ನೊಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಬರುತ್ತೆ. ನನಗೆ 2 ಫ್ರೀಕ್ವೆನ್ಸಿದು ಮಧ್ಯೆ ಒಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಬಳಸಬೇಕು. ಅವಾಗ ನಾನು ಎಷ್ಟು ಪೈಪ್ ತೆಗೆದುಕೊಳ್ಬೇಕು? Your graph will actually tell you that. ಆ ಗ್ರಾಫ್ ನೀವು ಎಕ್ಸ್ಟ್ರಾಪುಲೇಟ್ ಮಾಡಿದ್ರೆ ಯಾವ ಲೆಂತ್ ಆಫ್ ಪೈಪ್ಗೆ ಯಾವ ಫ್ರೀಕ್ವೆನ್ಸಿ ಬರುತ್ತೆ ಅಂತ ನೀವು ಈಸಿಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. That is science. That is what a scientist does every day. Okay, this kind of experiments. Okay, na? So idu one. So what kind of a wave is a sound wave? I must be told at what time I should wind up. At what time should I close so that I manage to complete within that time. ನಾನು ಬಿಟ್ಟರೆ ಸಾಯಂಕಾಲ ತನಕ ಇರ್ತೀನಿ. I'm not scaring you. Okay, until we get the answer, let's continue. They all studied that sound is a wave. So what kind of a wave is a sound wave? Longitudinal. So one way of demonstrating a longitudinal wave. ತಗೊಂಡ್ರಿ ಹಿಂದೆ go back. Okay, this is called a slinky. ಈಗ slinky ಇದೆಯಲ್ಲ ಇದರಲ್ಲಿ ಏನಾದ್ರು ಒಂದ್ ಕಡೆ ಹೀಗೆ ಟ್ಯಾಪ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ನಿಂತ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ ಒಂದ್ ಕಡೆ ಟ್ಯಾಪ್ ಮಾಡಿದ್ರೆ ನೋಡಿ ಆ ಟ್ಯಾಪ್ ಮಾಡಿದ್ದು ಅಲ್ಲಿ ತನಕ ಹೋಗಿ ಮತ್ತೆ ವಾಪಸ್ ಬರುತ್ತೆ right. So I'm causing a disturbance in this direction. The disturbance is also traveling in this direction. This kind of pulse or a wave is called a longitudinal wave. Sound allo ade rite agute. Bani. Sound allo ide tarane agutte. Product. Okay. So one of the ways in which you can show that this is longitudinal wave. Secondly, this longitudinal wave and the transversal wave agli. So there will be crests and troughs. Sure, right? Crest and the amplitude maximum irutte. Trough on the other side it will be maximum, which is like a minimum. Okay. Iveredu madhyadalli one nodes anta bರುತ್ತೆ. Nodes. So these are the points where in a standing wave or a stationary wave, there is no displacement. ಇದರಿಂದ ಪಲ್ಸ್ ಹೋಗಿ ವಾಪಸ್ ಬರ್ತಲ್ಲ. So continuous ಆಗಿ ನಾವು ಅದರ ಮಾಡ್ತಾ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ there will be compressions and rarefactions which will be in fixed places, which are called nodes. This is clear to you? Now these nodes and antinodes can be very tricky. When crest and the crest meet, the sound gets added up. When trough and the trough meet, sound gets added up, they become loud. But when the crest and the trough meet, they cancel out. What is this phenomenon called? It is superposition. So ಈ superposition ಹೇಗಾಗುತ್ತೆ ಅನ್ನೋದನ್ನ it is a simple demonstration. I have a buzzer in this pipe. Buzzer ಅಂದ್ರೆ ಗೊತ್ತಾ? Vehicles indicator ಹಾಕಿರ್ತಾರಲ್ಲ, speed, beep, sound. But this is going to produce a continuous sound. One simple experiment. Now all of you sitting in your place, just move your head like this much. What is it that you observe? What about the amplitude? Need amplitude minimum. Okay, now all those who are listening to the maximum amplitude, maximum amplitude is kayati. Okay, once again you can shift your head a little bit so that you know when it is maximum, when it is minimum. Alright? So you'll be able to answer my next question easily. So you can head stable agitpodi, straight agi. All those who are hearing the highest amplitude, raise your hand. No, you should keep your head stable. You should not move. ಎಷ್ಟು ಜನಕ್ಕೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರ್ತಿದೆ? ಮಿನಿಮಮ್ ಇರೋರು? Now I am going to do something. Is there any difference?
Yes, sir.
Yeah? So maximum error ki minimum banta?
Yes, sir.
For many of you, if not all. Okay. And this ಯಾಕೆ maximum minimum ಅಂತ ಇತ್ತು ನೀವು ಕಲೆ ಆಡಿಸ್ತಾ Sorry? The sound from that is coming at a constant amplitude actually. That buzzer is a single thing. It's producing sound at the same loudness, but when you move your head, the loudness is changing. Okay? Now this is because from these two ends, sound is coming out from these two ends. The buzzer is at the center, and sound from each of these ends will be reaching both your ears, but they reach your ears with a small time difference. ಈ ಕಿವಿಯಿಂದ ಈ ಕೇಳಕ್ಕೂ ಮತ್ತು ಈ ಕಿವಿಯಿಂದ ಕೇಳಕ್ಕೂ ಸ್ವಲ್ಪ ಟೈಮ್ ವ್ಯತ್ಯಾಸ ಇರುತ್ತೆ. ಫ್ಯೂ ಮಿಲಿಸೆಕೆಂಡ್ಸ್, ನಾಟ್ ಮಚ್, ಜಸ್ಟ್ ಫ್ಯೂ ಮಿಲಿಸೆಕೆಂಡ್ಸ್. ಬಟ್ ಅಷ್ಟು ಡಿಫ್ರೆನ್ಸ್ ಇಂದ ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಈ ಎರಡೂ ಸೌಂಡ್ಗಳಿದೆಯಲ್ಲ ಅದು ಸೂಪರ್ ಪೋಸ್ ಆದಾಗ ಕ್ರೆಸ್ಟ್ ಮೇಲೆ ಕ್ರೆಸ್ಟ್ ಬಂದಿದ್ರೆ, if your ear position is such that both the ears are getting crest, amplitude is high. If your ear is such that both are getting trough, still high. But if one is getting crest and another is getting trough, they cancel out, so it becomes a minimum. Okay, this is a beautiful way to show superposition. But just this is magic show again. Just this much. So now you have to plan an experiment in which you can do measurements. I will amplitude measure ಮಾಡ್ಬೋದು. So if you now connect this to a battery, it's producing the sound continuously, and if you keep moving your mobile phone like that at various places, see, unlike we who have 2 ears, it has only 1 ear. There's only one microphone. So it picks up sound from both the places through the same microphone. So illiruvaga the maximum amplitude ತೋರಿಸುತ್ತೆ. It will show a number. 1 centimeter ಈ ಕಡೆ ಬಂದ್ರೆ ಮಿನಿಮಮ್ ಬಂದ್ಬಿಡುತ್ತೆ, ಮತ್ತೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರುತ್ತೆ. ಸೊ ನೀವೇನ್ ಮಾಡ್ಬೋದಂದ್ರೆ ಒಂದು ಆಂಗಲ್ ತರ ಡ್ರಾ ಮಾಡ್ಬಿಟ್ಟು ಪ್ರೊಟ್ರಾಕ್ಟರ್ ತರ, ನಾವು ಯು ಮಾರ್ಕ್ ಆಂಗಲ್ಸ್ ಫ್ರಮ್ this at the center, so 10 degrees, 20 degrees, 30 degrees, 40 degrees like that ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು for every 5 degrees you keep measuring the amplitude. Now again plot a graph. For every 5 degrees how the amplitude is changing, you get a beautiful curve like that. It looks very nice. Then you can tell why it is happening within that 1 centimeter or 2 centimeters. Suppose instead of this beam buzzer, I use another buzzer with a different frequency. Will it also show minimum maximum for every 5 degrees? We don't know. So that depends on its frequency. So the frequency, ಎಷ್ಟು ಆಂಗಲ್ ಅದು ಮಿನಿಮಮ್ ಆಗುತ್ತೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನ ನೀವು these two how they are related ಅಂತ ನೀವು ಮಾಡಿದ್ರೆ it will be a wonderful experiment. ಇದು ಯಾವುದಕ್ಕೂ ನೀವು ನಿಮ್ಮ ಕಾಲೇಜ್ ಸ್ಕೂಲ್ ಫಿಸಿಕ್ಸ್ ಲ್ಯಾಬ್ ಹೋಗ್ಬೇಕಾಗಿಲ್ಲ. You can do these things at home. This buzzer you will find in any electric shop or automobile shop for 25 rupees, and you just need one 9-volt battery. ಅಷ್ಟೇ. ಮೊಬೈಲ್ ಫೋನ್ ಎಲ್ಲರ ಮನೇಲೂ ಇರುತ್ತೆ. ಆ್ಯಪ್ನ ಫ್ರೀಯಾಗಿ ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊಳ್ಳೋದು. All that you have to do is to draw a big protractor and then move this mobile phone along that protractor and measure every 5 degrees how amplitude is. When you do this, you have done a good experiment. Otherwise, it is just nice. You ಮಾಡಿದ್ರೆ ಅದು ಹೆಚ್ಚು ಕಡಿಮೆ ಆಗುತ್ತೆ ಅಷ್ಟೇ. That's not sense. Okay. So now remaining experiments I am not going into so much detail about measurement because I suppose that I have shown you how you can do it. Rest of the things you could just experiment demonstrations. ಈಗ ಸೌಂಡ್ ಅನ್ನು ನಾವು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? ವೈಬ್ರೇಷನ್ ಮಾಡೋ ರೀತಿ ಹೇಗೆ? How do you make something vibrate? By polarity. So if you have to produce sound in this pipe, how do you do that? Okay, that's what we did with that pipe. This is one way. This experiment is very nice for another reason. So what I am applying here is something called rosin powder. Rosin, R-O-S-I-N. This is used by people who play violin. Violin ನುಡಿಸ್ತಾರಲ್ಲ ಅವರು ಈ ತರದ್ದು violin ಗೋಗೆ ಅದನ್ನು ಹಾಕಿ ಉಡಿಸ್ತಾರೆ. If they didn't do that, they can't play violin at all. That's very important. And I am also going to play violin. In some sense, not exactly violin, but the violin produces sound for the same reason that this pipe produces sound. So hold it there. And the sound is there for a long time. Look at this expression. Okay? Sorry?
Is that normal or it's anything different?
Pipe, huh? Normal pipe, aluminum pipe ashte. So it produces beautiful sound. Maybe a bit irritating because frequency. So to play this, Dr. Subarna Sinha told you about art in science and science in art. When you do an experiment, you are both a scientist as well as an artist. ಈ ಪೈಪನ್ನು ಯಾರು ಕೊಟ್ಟರು ಅವ್ರಿಗೆ ಮಿಸ್ಟೇಕ್ ಬರಲ್ಲ ಅಷ್ಟು ಈಸಿಯಾಗಿ. ಯು ಶುಡ್ ನೋ ಹೌ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಟು ಹೋಲ್ಡ್, ವೇರ್ ಟು ಹೋಲ್ಡ್, ಎಷ್ಟು ಪ್ರೆಷರ್ ಹಾಕಬೇಕು, ಇದೆಲ್ಲ ಆರ್ಟ್. ಓಕೆ, ನಾನು ಮುಂಚೆನೇ ಮಾರ್ಕ್ ಮಾಡ್ಕೊಂಡು ಬಂದ್ಬಿಟ್ಟಿದ್ದೀನಿ ಇಟ್ಕೊಳ್ಬೇಕು. And also by practice I know where to hold it. Now you can also tell me where I am holding it. At the midpoint. ಯಾತಕ್ಕೆ ಮಿಡ್ ಪಾಯಿಂಟ್ ಅಂದರೆ ಇದು ವೈಬ್ರೇಟ್ ಆಗ್ತಾ ಇರುವಾಗ there will be sound waves going like that, getting reflected, going like that, getting reflected. ಇದು ಆಗ್ತಿರೋವಾಗ ಸ್ಟೇಷನರಿ ವೇವ್ಸ್ ಬರುತ್ತೆ. ಸೂಪರ್ ಪೊಸಿಷನ್ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ, ಅದು one wave ಮೇಲೆ ಇನ್ನೊಂದು wave ಆಡ್ ಆಗುತ್ತೆ. It's a center point which will have the node. Node will not have any displacement. So ನೀವು ಅಲ್ಲಿ ಇಟ್ಕೊಂಡಾಗ ಏನಾಗುತ್ತೆ, ಈ ಇಡೀ ಪೈಪ್ ಇದೆಯಲ್ಲ, that pipe will be vibrating at the frequency. Very hard to believe that actually it will be vibrating to produce that sound. Now what is the role of that rosin powder that I put there?
To make
Now if I were to take a different finger to which I have not applied rosin, just about comes because some rosin is sticking to this. It's a bit sticky. ಈ ಗಮ್ಮರ ಅಂತ ಬರುತ್ತೆ ಗೊತ್ತಾ ನಿಮಗೆ, ಅದು ಗಮ್ ತರ ಬರುತ್ತೆ. ದಟ್ ರೋಸಿನ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದಟ್. ಯಾವ ಫ್ಯಾನ್ಸಿ ಹೆಸರು ಕೊಟ್ಬಿಟ್ರೆ ಓ ಅಂತೀವಿ, ಅದು ಗಮ್ ಬರುತ್ತಲ್ಲ ಆ ಮರದ ಓ ಇದಾ. That's how we have. Anything that is very common and familiar, we have no respect. The moment you make it very unfamiliar and something out of this world, you have a lot of respect. So ಅದು ಗಮ್ಮರದ ಪುಡಿ, ಅದನ್ನ ಒಣಗಿಸ್ಬಿಟ್ಟು ಪುಡಿ ಮಾಡಿರ್ತಾರೆ. ಇದು ಹಾಕೋ ಉದ್ದೇಶ ಏನಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ, ಬೋತ್ ಫಾರ್ ವಯಲಿನ್ ಅಂಡ್ ಫಾರ್ ದಿಸ್, ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಸಮಥಿಂಗ್ ಕಾಲ್ಡ್ ಸ್ಟಿಕ್ ಅಂಡ್ ಸ್ಲಿಪ್ ಮೋಷನ್. ಸ್ಟಿಕ್ ಅಂಡ್ ಸ್ಲಿಪ್ ಇದನ್ನು ಬರ್ಕೊಳ್ಬೇಕು. ದಿಸ್ ಇಸ್ ಒನ್ ಮೋರ್ ವೇ ಆಫ್ ಪ್ರೊಡ್ಯೂಸಿಂಗ್ ಸಾಂಗ್, ಸ್ಟಿಕ್ ಅಂಡ್ ಸ್ಲಿಪ್. ಇದ್ರಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ, ಈಗ ಇಟ್ಕೊಂಡು ಎಳೆಯುವಾಗ ನಾನು ಬೆಳವಣಿಗೆ ಕೂಡ ಇದು ಪೈಪ್ಗೆ ಒಂದು ಮೂಮೆಂಟ್ ಅಂಟ್ಕೊಳ್ಳುತ್ತೆ. I to move, there is slipping. Again there is sticking. So sticking and slipping both. That is why this is producing sound. That produces a vibration. And for the same reason, a violin bow, ಇದಕ್ಕೂನ rosin powder ಹಚ್ಚಿರ್ತಾರೆ. So when they play over the violin wire, it sticks to the wire and slips. So if you are a violinist, ಯಾರಾದ್ರೂ violin play ಮಾಡ್ತೀರಾ? Anybody who plays violin? Nobody? If you are learning to play violin, you must know at what angle you have to move this and at what speed you have to move this to produce the kind of stick and slip motion you produce, because of which you produce sound of different frequencies and you produce sound of different amplitudes. It's art. but it is also science. You look at it. You don't worry about what the wire is doing and what the bow is doing, you're just playing like an artist. But when you want to find out at what speed this has to move with respect to the wire, string, then you're asking like a scientist. I have a special reason to talk about this because we are sitting here where Sir C.V. Raman walked around, and one of the most wonderful experiments that Raman did, that C.V. Raman studied scientifically, was the physics of the violin. Okay, when you go to the Raman Museum, perhaps you'll see there, physics of violin. But he was a genius. See, to play violin, you have to move this bow on the strings. But to make measurements, it's very difficult at what speed the bow is moving and things like that. So what he did was, he kept the bow constant and he made a machine in which the string would actually move. What you need is one should move with respect to the other. Relative motion, that's all. I don't know if Raman Museum has this particular experimental setup which Sir C.V. Raman used. It was an ingenious way of studying the physics behind the sound produced by violin. He did a lot of things. I'm going to show a couple of experiments very quickly. In time, I will explain them. 3:30, na?
24 rupees.
Huh?
24 rupees.
It's already 34. I should go back in time. To go back in time, I should travel faster.
It's 24.
24.
24. It's 24.
It's 24, huh? 6 minutes after. Then I'll quickly show you some of these experiments. So Sir C.V. Raman actually studied the physics behind the sound produced by a number of musical instruments. And in particular, his work on violin and his work on mridanga, outstanding. I'm going to show that experiment at the end because I would like you all to come closer and watch. Can you the That will be the last experiment I will show. Okay, so to show you one more experiment on stick slip motion, this is Chinese bow. You know it's very, very, very common. Right? ಇದನ್ನ ಇಷ್ಟು ದಿನ ನೀವು ನೋಡಿದ್ರಿ. ಇನ್ಮೇಲೆ ಏನ್ ಮಾಡ್ಬೇಕು? Measure ಮಾಡ್ಬೇಕು. Measure how the sound frequency varies. If you can get bowls of different diameters, how the diameter of the bowl affects the frequency of the sound produced. Okay? But ಇನ್ನೊಂದು which I forgot to pack. Wine glass ಅಂತ ಬರುತ್ತಲ್ಲ, which will have a stem and then there is a glass. ಈ ಥರದ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಥರ ಕರಿತೀವಿ. ಅದರಲ್ಲಿ ಸ್ವಲ್ಪ ನೀರು ಹಾಕ್ಬಿಟ್ಟು ಬೆರಳನ್ನು ಒಂಚೂರು ಒದ್ದೆ ಮಾಡ್ಕೊಳ್ಬೇಕು. ನೀರಿನಲ್ಲಿ ಸ್ವಲ್ಪ ಹೊತ್ತು ಇಟ್ಕೊಂಡ್ರೆ ಇದು ಸ್ಕಿನ್ ಎಲ್ಲ ಒಂಚೂರು ಸಾಫ್ಟ್ ಆಗುತ್ತೆ. ಇಟ್ ಬೆಂಡ್ಸ್ ಆಸ್ ಯು ವಾಂಟ್ ಇಟ್ ಟು ಬೆಂಡ್. ಈಗ ನೀರು ಹಾಕ್ಬಿಟ್ಟು ಅದ್ರ ಮೇಲ್ಗಡೆ ನೀವು ಹೀಗೆ ಉಜ್ತಾ ಇದ್ರೆ it produces a particular frequency. Okay? Now, how that frequency depends on how much of water is there in the wine glass is a beautiful project you can take up. Very easy to do, but the physics behind that is very challenging. You could try to derive equations and all that. If not today, you may do it 3 years from now. But remember this problem. It's called a singing wine glass. So wine glass ತಗೊಂಡ್ಬಿಟ್ಟು ಅದರಲ್ಲಿ ನೀರು ಹಾಕಬೇಕು. ನೀರು ಹಾಕ್ಬಿಟ್ಟು ಈಗ ಬೆರಳನ್ನು ಒದ್ದೆ ಮಾಡ್ಕೊಂಡು ನಿಧಾನಕ್ಕೆ ಹೀಗೆ ಮುಚ್ತಾ ಹೋದ್ರೆ ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ಸೌಂಡ್ ಆಫ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಎಷ್ಟೋ ಸಲ ನಾವು ಕಿಚನ್ ಅಲ್ಲಿ ನೋಡಿರ್ತೀವಿ, ಈಗ ವಿಮ್ ಡ್ರಾಪ್ ಈ ತರ ಲಿಕ್ವಿಡ್ ಸೋಪ್ ಹಾಕಿ ಸ್ಟೀಲ್ ಪಾತ್ರೆ ನಾವು ತೊಳೆದ್ಬಿಟ್ಟು ಆ ತಟ್ಟೆ ಮೇಲೆ ಹೀಗೆ ಮಾಡಿದ್ರೆ ಅಮ್ಮ ಅಡುಗೆ ಬಡಿಸೋ ಸ್ವಲ್ಪ ಲೇಟ್ ಮಾಡಿದ್ರೆ ಮಾಡ್ತೀವಿ. It's for the same reason, stick and slip motion. So to study these things, you don't have to go to a lab. Your kitchen itself can become a lab. Okay? So you have to first get the art of producing that sound. Then the app is there to make the measurements and you can play around. You ask questions and get answers from measurements.
ಎರಡು ಪಾಯಿಂಟ್ಸ್ ರೈಸ್ ಮಾಡಕ್ಕೆ ಪರ್ಮಿಷನ್ ಕೊಟ್ಟು ರೈಸ್ ಮಾಡಿ.
ನೀವು ಖಂಡಿತ
ಸರ್, ಒಂದನೇ ಪಾಯಿಂಟ್ ಪ್ಲಾನೆಟೋರಿಯಂ ಅಲ್ಲಿ ನಮ್ಮ ಮಕ್ಕಳಿಗೂ ಕೂಡ ಒಂದು ಆಪರ್ಚುನಿಟಿ ಕೊಟ್ಟು ನಿಮ್ ಜೊತೆ ಅಸೋಸಿಯೇಟ್ ಆಗೋಕೆ ದಯವಿಟ್ಟು ಅವಕಾಶ ಮಾಡಿಕೊಡ್ತೀವಿ. ಎರಡನೇದು, ನಿಮ್ಮ ಪ್ರಾಜೆಕ್ಟ್ಸ್ ಅಲ್ಲಿ ನಮ್ಮ ಹುಡುಗರನ್ನು ಇನ್ವಾಲ್ವ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಡೇ ಟು ಡೇ ಲೈಫ್ ಅಲ್ಲಿ ಏನು ಸೈನ್ಸ್ ಇದೆ ಅಂತ ಹೇಳಿ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಮಕ್ಕಳಿಗೆ ಮನ ಮುಟ್ಟೋ ಹಾಗೆ ಮಕ್ಕಳನ್ನ ಉಪಯೋಗಿಸ್ಕೊಂಡು ಪ್ರಾಜೆಕ್ಟ್ಸ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಸರ್ ಅವರು. ಗ್ರೇಟ್.
ಪ್ಲಾನೆಟರಿ is meant for such things.
Yes.
ಈಗ ಅವ್ರು ಮಾತಾಡೋದ್ರಿಂದ ನಾನು ಒಂದು ನಿಮಿಷ ಜಾಸ್ತಿ ಕೊಡ್ತೀನಿ. Okay, so ಇದರಲ್ಲಿ ವೈನ್ ಗ್ಲಾಸ್ ನಲ್ಲಿ ನೀವು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅನ್ನ ಮಾಡಿದ್ರೆ ಅನ್ಫಾರ್ಚುನೇಟ್ಲಿ ಐ ಕುಡ್ ನಾಟ್ ಡೂ ದಟ್. ಇನ್ನೊಂದು ನೋಡಿ ತುಂಬಾ ಸುಲಭವಾಗಿ ಎಲ್ಲ ಇದ್ರಲ್ಲಿ ಸೌಂಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋದು ಹೇಗೆ ಗೊತ್ತಾ? ಒಂದು ಈ ತರ ಮಾಡಿದ್ರೆ ಒಂದು ಸೌಂಡ್ ಬರುತ್ತೆ. ಇಸ್ ಇಟ್ ಪ್ಲೆಸೆಂಟ್ ಇದೆಯಾ? It depends on what is present. It's individual choice. Or I can do this. ಈ ಶಬ್ದ ಕೇಳಿದ್ರೆ ಯಾವ ತರ ಅನಿಸ್ತದೆ ನಿಮ್ಗೆ? ಬಕೆಟ್ ಅಲ್ಲಿ ನಲ್ಲಿಯಿಂದ ನೀರು ಬಿಟ್ಬಿಟ್ಟು ನೀರು ಬಿಡ್ತಾ ಹೋದ್ರೆ ಶಬ್ದ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಅದು ಯಾಕೆ ಚೇಂಜ್ ಆಗುತ್ತೆ ಗೊತ್ತಾ? Because of the distance of height of water, the air column will be different. So ಅದು ರೆಸೊನೇಟ್ ಆಗೋ ಲೆಂತ್ ಇರುತ್ತಲ್ವ ಅದು ವ್ಯತ್ಯಾಸ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಹೇಗೆ ಲೆಂತ್ ಚೇಂಜ್ ಮಾಡೋದ್ರಿಂದ ಸೌಂಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ವ್ಯತ್ಯಾಸ ಆಗುತ್ತೆ ಅದರಲ್ಲೂ ಅಷ್ಟೇ. ಇವಾಗ ನಾವು ಎಷ್ಟೋ ಸಲ ಈ ತರ ಮಾಡಿರ್ತೀವಿ, ಪಾತ್ರೆನಲ್ಲಿ ನೀರು ತುಂಬಿಸೋದಕ್ಕೆ ಬಿಟ್ಬಿಟ್ಟಿರ್ತೀವಿ, ಇಲ್ಲೇನೋ ಕೆಲಸ ಮಾಡ್ತಾ ಇರ್ತೀವಿ, ಆ ಪಾತ್ರೆ ತುಂಬಿತು ಅಂತ ನಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಇವನ್ ವಿತೌಟ್ ಲುಕಿಂಗ್ ಅಟ್ ದಟ್. That's a fantastic application of resonance. You have been trained how the length of the air column is affecting the frequency. ಯಾವ ಫ್ರೀಕ್ವೆನ್ಸಿ ಬಂದಾಗ ಅದು ತುಂಬಿದೆ ಅಂತ ನಿಮಗೆ ಗೊತ್ತಾಗಿದೆ. ಯಾಕಂದ್ರೆ 2 ಸಲ ಬಯಸ್ಕೊಂಡಿರ್ತೀರ, ಅದು ಚೆಲ್ಲೋದಕ್ಕೆ ಬಿಟ್ಬಿಟ್ಟು ನೀವು ಬಯಸ್ಕೊಂಡಿರ್ತೀರಿ. ಸೊ ನಿಮ್ಗೆ ಗೊತ್ತು ನೆಕ್ಸ್ಟ್ ಕಟ್ ಆಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಎಲ್ಲಿದೆ ಅಂತ. ಸೊ ಹಾಗಾಗಿ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ that careful there. Now you do the same experiment with this app. ಎಷ್ಟೆಷ್ಟು ನೀರಿದ್ದಾಗ ಅದರ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಹೇಗೆ ಚೇಂಜ್ ಆಗುತ್ತೆ? ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ಮತ್ತೆ ಫ್ರೀಕ್ವೆನ್ಸಿನೂ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಇದು ಎಷ್ಟು ನೀರಿದ್ದಾಗ ಎಷ್ಟು ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂತ ಕಂಡುಹಿಡಿದಿದ್ದೀರಾ? ಅದು ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗುತ್ತೆ. ನಲ್ಲಿನಲ್ಲಿ ನೀರು ಬಿಟ್ಟಾಗ ಏನಾಗುತ್ತೆ, ಅದು ಚೇಂಜ್ ಆಗ್ತಾನೆ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ಒಂದು ಸುಲಭ ಉಪಾಯ ಇದೆ. ಈ ಥರದ ಒಂದು ವಾಟರ್ ಬಾಟಲ್ ತಗೊಂಡ್ಬಿಡೋದು, ವಾಟರ್, and instead of air falling there, I use a pipe like this. Now I will do what you normally do in the class when the class is boring. Okay? No matter. ಪೆನ್ ಕ್ಯಾಪಲ್ ಮಾಡಿದ್ರೆ ಚೇಷ್ಟೆ ಅಂತ, ಇದ್ರಲ್ಲಿ ಮಾಡಿದ್ರೆ ಸೈನ್ಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. But it is the same thing that we are doing. Now observe, this is a hollow pipe. This is a last more after this. Okay, now I'm going to lift this all the way down and I blow air into this. There is some sound produced. Okay? It has, what are the two characteristics of that sound you can measure now? Frequency and amplitude. Fantastic. ಸ್ವಲ್ಪ ಮೇಲೆ ತೆಗಿತೀನಿ. ವ್ಯತ್ಯಾಸ ಆಯ್ತಾ? ಯಾವ್ದ್ರಲ್ಲಿ? ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಅಲ್ಲಿ ಎರಡಲ್ಲೂ ಆಗಿರ್ಬೋದು. So for various lengths of this pipe, gone into this, you can actually establish a relationship. ಹೇಗೆ ಫ್ರೀಕ್ವೆನ್ಸಿ ವ್ಯತ್ಯಾಸ ಆಗುತ್ತೆ, ಹೇಗೆ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ವ್ಯತ್ಯಾಸ ಆಗುತ್ತೆ. Is it an expensive experiment? So next time water bottle ಏನನ್ನ ಕೊಟ್ರೆ water bottle ಬಿಸಾಕ್ಬೇಡಿ. Use it for this experiment and do it for water bottles of different diameters, different heights. When you learn to gather data and plot relevant graphs. You would have done what a scientist does. Okay? Maybe in ಎರಡು experiment ತೋರಿಸ್ತೀನಿ. Oh, I didn't show you this. Frequency changes. A fantastic way to produce sound is this. The speed ಜಾಸ್ತಿ ಮಾಡ್ತಾರೆ. ಫಸ್ಟ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಈಗ ಜಾಸ್ತಿ ಮಾಡ್ತೀನಿ. Frequency is increasing. And again, you don't have time. So these measurements we can easily go with the app. So what you can do is, either pipe design sigatre. Beautiful thing about this is you can change the level. ಇಷ್ಟೇ ಇರುತ್ತೆ. ಇನ್ನೊಂದು ಶಬ್ದ ಯಾವ ಥರ ಬರುತ್ತೆ? For the same speed, we can try to do this. So you can vary the length, you can vary the distance between collocations. Now, is the air going from bottom to top or top to bottom? That is your opinion. Now, how do I test it? How do I test it? A simple way in permission ಇದೆ ಮನುಷ್ಯ ತಗೊಳ್ಳೋದಕ್ಕೆ. So what they do is, see, these are all simple tricks actually. You don't need sophisticated equipment to do science. Just a bit of imagination. ಚೇಷ್ಟೆ ಮಾಡಕ್ ಬರ್ತೈತೆ. ಯಾರು ಜಾಸ್ತಿ ಚೇಷ್ಟೆ ಮಾಡ್ತಾರಲ್ಲ ಅವ್ರ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ ಚೆನ್ನಾಗಿ ತುಂಬಾ ಗಂಭೀರವಾಗಿರೋ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ಚಿಕ್ಕ ಚಿಕ್ಕ ಪೀಸಸ್ ಮಾಡ್ಕೊಳ್ತೀನಿ. ಇದನ್ನ ಮಾಡ್ಬಿಟ್ಟು ಏನ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ, ಇದನ್ನ ನಂದು ಕೈ ಮೇಲೆ ಇಟ್ಕೊಂಡಿರ್ತೀನಿ ಲೂಸ್ ಆಗಿ. Now I will hold it like this and I will rotate. If air is coming from bottom to top, what is the indication? Vapor also should come out. If air is going from top to bottom, vapor should be blown away from this. So you should carefully observe. ನಾನು ಸ್ವಲ್ಪ ಇಲ್ಲಿ ಶೇಕ್ ಮಾಡ್ತಾ ಇದ್ದೆ, because of gravity also it comes down, and so it doesn't settle that question. So how do we settle the question? I leave it at this stage so that you have something to carry home. It's very easy to do. So ಇನ್ಯಾವ ತರ ಮಾಡ್ಬೋದು? ಈ ಪೇಪರ್ ಅಲ್ಲಿ ಇನ್ಯಾವ ತರ ಮಾಡ್ಬೋದು? ನಾನು ಈ ಕಡೆ ಹೋಗ್ತಿದ್ದೆ, ಆ ಕಡೆ ಬರ್ತಿದ್ದೆ. Can you suggest quickly some idea? A table ಮೇಲೆ ಪೇಪರ್ ಇಟ್ ಮಾಡ್ಬೋದು. Table does not take something, but I will not do it because I would like you to try something at going home. You know, they will take home. Some mesh it put ಮಾಡ್ಬೋದು. It's a beautiful idea. What is a round table? Any other quickly? One more. That's all. ಅಗರಬತ್ತಿ ಸಾಂಬ್ರಾಣಿ ಹಚ್ಬಿಟ್ಟು ಇಟ್ಬಿಡೋದು. ಸೊ ಹೊಗೆ ಆಚೆ ಕಡೆ ಬಂತು, ಫಾಸ್ಟ್ ಆಗಿ ಬಂತು ಅಂದ್ರೆ ಇಲ್ಲಿಂದ ಬರ್ತಿದೆ ಅಂತ, ಕೆಳಗಿಂದ ಮೇಲೆ ಹೋಗ್ತಿದೆ. ಮೇಲಿಂದ ಕೆಳಗಡೆ ಹೋಗ್ತಿದ್ರೆ then it will spread out like that. ಅಲ್ವಾ? So something which will help you to see the motion of air. You can't see air itself, but the effect of motion of air you can see. Various ways. Okay? But ಇದನ್ನ ಏರ್ ಬರಲಿ ನೀರ್ ಮೇಲೆ ಇಟ್ಬಿಟ್ಟು ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಈ ತರ ಬಟ್ ಫಾರ್ that you should need this. ಇದೆಲ್ಲ ಕಡೆ ಸಿಗುತ್ತೆ ತಾನೆ? So what should you do as soon as you go home to the kitchen today? See, I will easily escape. I'm saying this. My parents will get after Mr. Shubhankar. ಯಾರು ಈ ಪ್ರೋಗ್ರಾಮ್ ಆರ್ಗನೈಸ್ ಮಾಡಿದ್ರು? ಓಕೆ, ನಾಳೆ ಹೇಳಿದಾಗ ಒಂದು ಸರ್ ಸಿ ವಿ ರಾಮನ್ ಅವ್ರಿಗೆ ಫಿಸಿಕ್ಸ್ ಆಫ್ ಮ್ಯೂಸಿಕಲ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಇದೆಯಲ್ಲ, ಅದು ತುಂಬಾ ಇಂಟ್ರೆಸ್ಟ್. ಒಂದು ಕಲರ್ಸ್ ಬಗ್ಗೆ ತುಂಬಾ ಇಂಟ್ರೆಸ್ಟ್ ಇತ್ತು, ಇನ್ನೊಂದು ಮ್ಯೂಸಿಕಲ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್. ವಯಲಿನ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂಗೆ ಅದು ತುಂಬ ಉತ್ತಮವಾದಂಥ ಕೆಲಸ ಮಾಡ್ತಾರೆ. And as I told you, his genius that he didn't allow the bow to move. He kept the bow constant, but he moved the string. That way he had a control over at what speed the string has to move, at what angle this has to move. ಇದೆಲ್ಲನೂ ಕಂಟ್ರೋಲ್ ಇತ್ತು. ಹಾಗಾಗಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡೋಕ್ಕೆ ತುಂಬ ಅನುಕೂಲ ಇದೆ. ಎರಡನೇದು ಅಂತ ಹೇಳಿದ್ರೆ ಮೃದಂಗಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಾಗ he always felt that Indian percussion instruments are more musical than the western counterparts. ಈಗ ಇವರು ಕೆಟಲ್ ಡ್ರಮ್ ಅಂತ ಹೇಳಿದ್ರೆ ಈ ಕೆಟಲ್ ಡ್ರಮ್ ಅದೆಲ್ಲ ತುಂಬ ಕರ್ಕಶವಾಗಿರುತ್ತೆ ಕೇಳೋದಕ್ಕೆ, ಆದರೆ ಅದನ್ನೇ ತುಂಬ ಎಂಜಾಯ್ ಮಾಡೋರು ಇರ್ತಾರೆ. ದಟ್ಸ್ ಎ ಡಿಫ್ರೆಂಟ್ ಸೆಟ್ ಆಫ್ ಪೀಪಲ್. Now he wanted to prove why Indian musical instruments are ಮೃದಂಗ is more musical than kettle drums. Kettle drum ಅಂದರೆ ಅದೊಂದು ದೊಡ್ಡ ಸ್ಟೀಲ್ ಪಾತ್ರೆ ಥರ, ಅದ್ರ ಮೇಲೆ ಬಡಿದ್ರೆ ಶಬ್ದ ಬರುತ್ತೆ. That's a simplest description. So what he did was he took the ಮೃದಂಗಂ, ಆ ಮೃದಂಗಂ ಮೇಲೆ ನೀವು ಒಂದು ಸಲ ಬಡಿದ್ರೆ ಅದು ಮೆಂಬ್ರೇನ್ ವೈಬ್ರೇಟ್ ಆಗುತ್ತೆ. That's how it produces the sound. ಆ ಸೌಂಡ್ ಪ್ಯಾಟರ್ನ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡೋಕ್ಕೆ ಏನು ಮಾಡಿದ್ರು ಅಂದರೆ ಅದ್ರ ಮೇಲೆ ಲೈಕೋಪೋಡಿಯಂ ಪೌಡರ್ ಅಂತ ತುಂಬ ಫೈನ್ ಬಯಾಲಜಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇರ್ಬೋದು. ಲೈಕೋಪೋಡಿಯಂ ಇಸ್ ಎ ಸ್ಪೋರ್, ಆಲ್ಮೋಸ್ಟ್ ಸೇಮ್ ಸೈಜ್ ಇರುತ್ತೆ, 25 ಮೈಕ್ರಾನ್ಸ್, ಸ್ಪೆರಿಕಲ್. ಅದನ್ನು ಮೇಲೆ ಉದುರಿಸ್ಬಿಟ್ಟು ಅದು ಎಲ್ಲೆಲ್ಲಿ ನೋಡ್ ಇಸ್ ಅ ಪಾಯಿಂಟ್ ಆಫ್ zero displacement, nearly zero displacement. This is in one dimension when you take a thread, but when you take a flat thing like this in 2 dimension, a node will not be a point, it will be a line. So in an entire line where there is no vibration, ಇದನ್ನು ನಾವು ಮೃದಂಗದ ಮೇಲೆ ಹಾಕ್ಬಿಟ್ಟು ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಸೊ ಐ ಆಮ್ ಕಂಬೈನಿಂಗ್ ದೋಸ್ ಟು ಎಕ್ಸ್ಪೆರಿಮೆಂಟಲ್ ರಿಸಲ್ಟ್ಸ್ ಇಂಟು ಒನ್. ಈ ವಯಲಿನ್ ಥರ ಮಾಡ್ಕೊಂಡಿರೋದು ಜಸ್ಟ್ ಟು ರಿಮೈಂಡ್ ಅಸ್ ದಟ್ ಸರ್ ಸಿ ವಿ ರಾಮನ್ ಡಿಡ್ ದಿಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಐ ಡೂ ಗಿವ್ ಟಾಕ್ಸ್ ಆನ್, I recreate many of the experiments that Sir C.V. Raman did originally. They are very easy to do. Don't think I am great. They are very easy to do. That was his greatness. A simple experiments he expected, very interesting science. ಇದ್ರ ಮೇಲೆ ಮರಳನ್ನ ಸುಮ್ಮನೆ ರ್ಯಾಂಡಮ್ ಆಗಿ ಹಾಕ್ಬಿಡೋದು. ಮಾಡಿದ್ವಿ ನಾನು. ಈ ವಯಲಿನ್ ಬೋ ಇದೆಯಲ್ಲ, ಇದನ್ನ ತಗೊಂಡ್ಬಿಟ್ಟು ಇದರಿಂದ ಈಗ ಮಾಡಿದ್ರೆ it vibrates the entire plate. It vibrates the entire plate. ಯಾವ ಮೆಕ್ಯಾನಿಸಮ್ ಇಂದ ವೈಬ್ರೇಟ್ ಮಾಡೋದು? ರೋಸಿನ್ ಪೌಡರ್. ಈಗೇನಾಗುತ್ತೆ ಅಂದರೆ ವೈಬ್ರೇಟ್ ಆದಾಗ there will be some points of zero amplitude, some points which are of higher amplitude. So ಎಲ್ಲೆಲ್ಲಿ zero amplitude ಇರುತ್ತೆ, ಈ ಮರಳಿಂದು ಕಣಗಳಿಂದ ಅದೆಲ್ಲ ಅವ್ರಿಗೆ ಅಲ್ಲಿ ಸೆಟ್ ಆಗುತ್ತೆ. So observe it. ಎಲ್ಲ ಕಡೆ ಬಳ್ಳಿನ ಕಣ ಹಾಕಿದ್ರು ಕೂಡ look at the nice pattern comes there.
ಮತ್ತೆ ನಾವು ಜೋಡಿಸ್ತಾಕಂತ
Okay, depending on the frequency that I produce, they get rearranged. These are all points of zero amplitude for that particular frequency in which I am exciting this. Okay, then I can have ಈಗ ರ್ಯಾಂಡಮ್ ಆಗಿದೆ ತಾನೆ, ನಾನೇನು ಪ್ಯಾಟರ್ನ್ ಜನರೇಟ್ ಮಾಡಿಲ್ಲ. So by studying these patterns on Mridangam, he showed that Indian percussion instruments are more musical than the Western percussion instruments. Okay, but our ಮಾಡಿದ್ದು by tapping. But I am using this one so that we can combine two experiments and make it into one. Okay, right. So thank you all for your patience. This experiment
Pay attention, please.
This experiment was done by one of my students at the planetarium. Very recently he completed his PhD. ಆ ಹುಡುಗ ಹೈಸ್ಕೂಲಲ್ಲಿ ಇದ್ದಾಗ ನಿಮ್ಮ ಥರ ಕಾಲೇಜಲ್ಲಿ ಪ್ಲಾನೆಟೇರಿಯಂ ಕ್ಲಾಸಸ್ ನಡೆಸ್ತೀವಿ ಅದಕ್ಕೆಲ್ಲ ಬರ್ತಾ ಇದ್ದ ಹುಡುಗನು ಪವನ್ ಕೌಶಿಕ್ ಅಂತ. So recently he completed his PhD and he went to Germany to pursue his postdoc. PhD happen ಮಾಡ್ತಾರೆ. He gifted me this. It is handcrafted by him exclusively for me. ನನಗೆ ತುಂಬಾ ಖುಷಿ ಆಗ್ತದೆ. ಅದನ್ನ ನಾನು ಮುಂದೆ ತೋರಿಸ್ಬೇಕಂತ ಹೇಳಿ ಇದೇ ತರ ಏನೋ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಿರ್ತೀವಲ್ಲ ಅವ್ನಿಗೆ ಯಾವ್ದೋ ಒಂದು ಇನ್ಸ್ಪೈರ್ ಆಗಿರೋದು. ಇದೇನಂದ್ರೆ ಈ ಕ್ಯಾನ್ ಯು ರೆಕಗ್ನೈಸ್ ದಿಸ್ ಆಬ್ಜೆಕ್ಟ್ ಯಾವ್ದ್ರಿಂದ ಪೋರ್ಟಬಲ್ ಗ್ಯಾಸ್ ಸಿಲಿಂಡರ್. ಪೋರ್ಟಬಲ್ ಗ್ಯಾಸ್ ಸಿಲಿಂಡರ್ ತಗೊಂಡ್ಬಿಟ್ಟು ಈ ತರ ಇದು ದೊಡ್ಡ ಹೋಲ್ ಮಾಡಿದ್ದಾರೆ. ಆಮೇಲೆ ಈ ಕಡೆಗೆ ಏನ್ ಮಾಡಿದ್ದಾರೆ ಅಂದ್ರೆ ಒಂದಷ್ಟು ಪರ್ಟಿಕ್ಯುಲರ್ ಶೇಪ್ ಅಲ್ಲಿ ಅಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಡಿಸ್ಟೆನ್ಸಸ್ he has actually cut a little bit. ಈಗ ಕಟ್ ಮಾಡಿದ್ದಾರೆ. ಬೇರೆ ಬೇರೆ ಥಿಕ್ನೆಸ್ ಇದೆ, ಬೇರೆ ಬೇರೆ ಲೆಂತ್ ಇದೆ. And see what it actually does. You can actually play at this. Right? And this is music part. He has also worked out the physics behind the entire thing, and he has donated that as some kind of a project work for me. And then he said there are so many open questions which he has not answered, which students can answer by taking up a project. It's not as a ಕಷ್ಟ ಇದೆ, but ಈ ಟೂಲ್ಸ್ ಇತ್ತು ಅಂದ್ರೆ ಅದನ್ನ ವೆಲ್ಡಿಂಗ್ ಶಾಪ್ ತಗೊಂಡು ಹೋಗಿ ನೀವು ಈ ತರ ಟೂಲ್ಸ್ ಕಟ್ ಮಾಡ್ಕೊಳ್ಳೋದು ತುಂಬಾ ಸುಲಭ. All you need is one junk portable cylinder like this, gas cylinder. ಅದರಲ್ಲಿ ಈ ತರ ಬೇರೆ ಬೇರೆ ಥಿಕ್ನೆಸ್ ಇದು ಮಾಡಿದ್ದಾರೆ. It produces a wonderful sound. What I want to demonstrate with that is that ನಿಮ್ಮ creativity-ಗೆ there is no limit. I don't know from where he got the inspiration to cut like this. ಈ ತರ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಬರುತ್ತೆ ಅಂತ. He must have thought deeply about these things for a long time. So if you keep thinking, then I'm sorry. Off agala. So if you keep thinking deeply about any problem, you will get ideas like that. That's what happens in every scientist's life. Ideas don't come every day. You are walking to a lab and do an experiment. There will be 3 months, 4 months, 6 months without anything, but you are continuously thinking. Suddenly there is a flash of idea one day. So, to summarize, some experiments I definitely wanted to show, but more importantly, I wanted to convey to you that these experiments are useless, they are meaningless, they are nonsense if you don't make any measurements related with this. And I have also discussed with you how you can carry out this. I have to download my free access and you can continue. And if you have any interesting things that you have discovered and you would like to come and share with me, I am always available at the planetarium. So please do come. And Bapuji school, Bapu school is not due to the planetarium. Sunday teachers do it. I don't know if he's still there. So he used to bring children to the planetarium. So Bunny everyone, so that's an invitation to you all to come to the planetarium. And thanks to Shabankar and his team.